J. Can you click on your J6 first? That's a 0.09 because I have 0.9. I don't know where.
Use 1,000 to divide it.
I thought it was supposed to be raised to power 2 for this.
No.
No, 3.
3. You use for you to know what to do here, what you should raise it to, you use the highest number. The maximum number here is 1,000. So it's 1,000 you are going to use to make that decision. Okay. Why? Because if you use, let's try it now. If you use to the power of 2, then it will break the rule for decimally scaled scores. Can you see this is already greater than 1, which is not allowed. Thank you. Which is not allowed. Okay. So that's why we cannot use that. So it has to be 3. Yes, I know. Thank you. So I hope that's clear.
Yeah. So, sorry, you were saying something about how you remove the minus sign or something. I didn't get it.
How?
You remove the minus signs from the Z-score.
Minus signs? No. I didn't
From
say
the
you
Z-score.
remove. I didn't say you remove minus sign. What I was saying is,
Okay.
when you do Z-score transformation,
Okay.
you will always have plus and minus figures. Some
Minus.
figures will be plus, some will be minus. Why? Because every value that is less than the mean, I mean the average, will have negative Z-score value. Let me show you.
Yeah.
Let me show you. Is it clear now?
Yes, sir. Yes.
Nah, because hope you remember the reason for that. Remember
Because
here.
the plus and minus. That's the plus and minus.
Yes. Yes. At the middle here, we have the mean.
Yeah.
Anything less than mean must be minus something.
Minus 1.
Anything
minus
greater
something.
than mean will not have minus. Yeah.
Yeah.
When you do Z-score transformation. Yes.
Sorry, sir. Question.
Yes.
How do you refer this to like in the life scenario? Like,
What do you? Okay.
how do we relate this to a life scenario? Like,
okay, you mean the okay. Yeah.
yes.
Okay. Well, in real life, you see, data transformation in real life. What can you see on your screen? Is it Excel or
Excel.
okay? In real life, that's in practical terms. Like I said, what did I say is the purpose of transformation? I said it helps to streamline data.
Yeah.
Yeah. So when you are working on data, especially when we are working on data that are large, voluminous, okay, when you transform the data, it makes it more efficient to process the data.
Okay.
In fact, when you are using there are some models, some data science models, when you are working with them, it's compulsory. You have to transform the data first. Okay.
Okay.
Yeah. So it's highly applicable. It's a very, very important topic, data science and data analytics. There's something you should understand. See, there's something you should understand. Let me go back to that Excel. So let me explain something to you. See, if If, for example, you do your transformation, you transform the data, it doesn't change the final result that you are going to get.
It's fixed.
Yeah, it will not change your final result. Okay. See, all you need to do is let's take this value, for example. Or let's take this one. We have said that how did we arrive at this one? We said equals x minus minimum
Minimum divided by x
divided
maximum
by maximum
minus minimum.
minus minimum.
Minimum. Yeah.
That's how we got it. Okay.
Yeah.
That's how we got it. So if I don't want to complicate anything right now, but if you use this transform data for computation, and then you get a certain answer, whatever answer you get, that answer can be transformed back to the original form for you to have the answer in the original form if desired. In some cases, if necessary. But in most cases, it's not necessary. Okay. Now, if you want to get this value back, it's just to do normal change of subjects formula. I don't know if are we still on the same page now? Just do
That's
change.
right, sir.
Yes, just do change of subject, and you get the original value back. Okay, but maybe we shouldn't go into that now. Maybe in the next class when our brains are still fresh. Okay,
It's okay.
but I'm just trying to explain to you that when you transform a data, nothing is lost. There's no loss of value. There's no loss of value. Why? Because you see the relationship between this number and this number now, this 97, value of this 97 relative to 94 is the same as 0.97 relative to 0.94. It's the same.
Okay.
Are you following?
Yeah.
Yeah.
Yes.
So nothing is lost. Nothing is lost at all. Okay. So that's it. It doesn't mean that you have actually, although the numbers have been transformed to some smaller figures, but when you use them for computation, the relationship between the numbers is conserved. There's no loss. Just no problem.
Okay, sir.
But the computation will be faster because the computer needs to handle small numbers instead of larger numbers. That's it. So your question was probably what is the real life application? I don't know if I have sufficiently answered your question. Okay.
Yes, sir.
Yeah, it is very, very applicable, especially in core data science. Especially in regular data analytics.
Data analytics.
We can also use it. but it's
Okay.
mostly used in core data science because many machine learning models require data transformation.
Transformation.
Yes. When you are doing some machine learning models, it's a must. You must do data transformation. But many of our operations, we may not need to do that. But it's good to know it.
Yeah.
Just have the knowledge. Just have
Okay,
the
sure.
knowledge. Because like I explained to you guys from time to time, you may find yourself working in an environment where you have a mixture of you have data scientists and data analysts, and then maybe there's a data scientist, who is higher than you. The data scientist may delegate this kind of task to you. They just give you some data and say, please help me transform this data for me. I'll need it in this form. I need it in this man, that. Your duty may just be to do the transformation, prepare the data, and give to him while he uses it to run his machine learning models. Charles, is it clear?
Yes, very clear, sir.
Okay. All right. So I think we've so what I'll do, I'll send an assignment. I'll send you some data which I want you to transform for me. Okay. And then send me the results. So
All right.
the different figures this time around. So I would like to, so you will do the transformation, send me the results. So I'll see if I can send out this night. If not, I think I have all our emails, so it may be in the form of email. Whichever the case, I'll let you know the moment I send it.
Okay, sir.
All right. So is there any other question before we? I don't want us to exceed 9:30. Everybody.
I think there's this core formula. I didn't see it.
Which one?
Is this core the formula for the Z score?
You didn't see it.
No, it's like it was. Well, I thought we have it on what's it called?
The PowerPoint.
Yes.
Yeah, let me show it to you.
Okay. It's a decimal. No, it's okay. X minus me is the okay. I think I forgot about that. Yeah, right down.
Okay, it's clear now.
Just hold on, sir. Z score is X minus me. Brackets. Yes. Thank you very much.
Okay, thank you, sir.
Yes, sir.
All right, so I think that will be it for today. Or is there any other question?
No.
In the absence of questions, we will that will be it.
We are jumped to the till on Thursday.
Till on Thursday, yes, and on Thursday, please let's ensure we do our assignments, please. Each of us should have at least 20 records, at least. Yeah, so we can follow. Otherwise, we won't be able to follow the class properly.
Yes,
So let's ensure we do that first. That will help us. And also let's endeavor to come in as early as possible. Yeah. So we can all move together at the same pace. As early as possible, please let's join the class.
Okay, sir.
Thank you very much. And, good night.
Okay, sir. Good night, sir.
Good
I
night.
tell you, we hope to get the video of this particular class.
This one. Okay. Okay.
Yes.
I'll
Yes.
send. I'll send. No problem.
Okay.
It's a very important one.
Yes.
Good night, sir.
Good night, sir.
Right.
Good night. Good night, everybody.
Good night, sir.
Good night.